Hello everyone, infosecpandey here and welcome back to the channel. So today we are going to cover Microsoft Sentinel Interview Mastery course, and this covers the 100 modern in-depth questions which covers KQL, Log Analytics, SOAR, threat hunting and cloud native SIEM architecture. So we have different labels. We have 20 questions for beginner, 35 for intermediate level, 30 for advanced level, and 15 for expert level. And what are the key topics we are going to cover? So we are going to cover the core concept of Microsoft Sentinel, KQL queries, analytics rule, SOAR playbooks, threat hunting, connectors, incidents, workbooks, and architecture. So instead of just memorizing Microsoft Sentinel interview questions, today I am going to explain them in a way you can actually understand and use in real interviews. So I will not just give answers, I will break them down and give examples and also tell you what interviewers are actually expecting. So let's get started with the basics. All right, so the first question we have, what is Microsoft Sentinel and how does it differ from a traditional on premises SIEM? So, Microsoft Sentinel is a cloud native SIEM, the security information and event management tool, and SOAR, the security orchestration, automation, and response platform. So, this is built on Azure Log Analytic, and unlike traditional SIEMs like Splunk, Curadar, ArcSight, Sentinel require zero infrastructure, so no hardware, no OS patching, and this also scales elastically with cloud ingestion. So this handle the petabyte data natively. It uses the KQL query, the Custo query language instead of SPL and AQL. So if you know SQL language, you can easily write the KQL queries. And this builds on pay as you go ingestion and GB per day, or there are some commitment tiers. And this is natively integrated with entire Microsoft's security ecosystems like Defender, Intra ID, Purview, Defender for Cloud, etc. So Microsoft Sentinel is a cloud native SIEM. Like, so this is your Sentinel instance, and this is created inside the cloud. So that's why it is called cloud native SIEM. And the cloud is Azure. So Sentinel comes with two solution. One is SIEM and one is SOAR. So SIEM is basically which collect data from systems, various systems like server, firewall, and your applications, your user data, and this help detecting threats. So first it collect the data, then it detect the threat detection. And the SOAR means SOAR is like a security orchestration and automated response. So this means it doesn't just detect the threat, it can also automate actions like automatically block the IP or isolate the machine and uh, send some notification alerts, etc. So the important part is like everything is cloud native, and that means like traditional SIEM like Splunk, Curadar, Sentinel doesn't require you to manage on-prem servers, storage, or infrastructure. So the old SIEM, if you are familiar with the old SIEM, you need to install the servers. So install servers, and you need to manage storage, and scale manually. So suppose your firewall started ingesting 100 GB data instead of just 10 GB data, you need to scale your sizing, right? But in the current SIEM, the Sentinel, the cloud native SIEM, you need to just enable it on Azure. So you can go on the Azure, create one subscription, and then you need to create a resource group, and then you can enable the Microsoft Sentinel, enable Sentinel. So this take hardly 10 minutes. So you can deploy the full Microsoft Sentinel within 10 minutes. Data integration will take some time, but the cloud native data integration also can be completed within half an hour. So within half an hour, you can complete everything which is on cloud, and also no maintenance is needed. So why interviewers ask this question? Because they want to check if you understand cloud advantage versus traditional SIEM. So the smart line you can add in your interview: Sentinel reduce operational overhead and provide elastic scalability, and it is cloud native SIEM, so you can set up within 1 hour. All right, so we have second question here. Explain the log analytic workspace, the LAW relationship with Microsoft Sentinel. So Microsoft Sentinel is essentially a layer of security intelligence on top of log analytic workspace. So this is your log analytic workspace, and this is your Sentinel. Sentinel. This is LAW. So when you enable Microsoft Sentinel, you need to select the existing log analytic workspace, or you need to create one. So log analytic workspace equal to database, where we can collect the log, query the log, and store the log. So this is basically a database server. And Microsoft Sentinel is built on Log Analytic Workspace. And a single Sentinel can have multiple LAWs, the Log Analytic Workspace. All right. So all data ingested flow into tables within that workspace. So whatever data we are ingesting from outside, like server, firewall, endpoints, everything will go to Log Analytic Workspace, and here it will create the indexing table. So suppose you are receiving the Windows data, so it will create an indexing table here: Windows events, Windows events. And if you have the firewall data, so it will create a pan table here. Or you have G-scaler data, so that will create another table here. And this will be easy to write the query and uh, filter the data easily. So the workspace store data using Azure Data Explorer technology under the hood. So Log Analytic Workspace have Azure Data Explorer engine. So where you can write the query, where you can save the data, set the retention period. Also, you can run your query here. So like KQL queries run directly against Log Analytic Workspace table. So suppose you have security events, Azure activity events, you can run directly on Log Analytic Workspace. And multiple Sentinel instance cannot share the same Log Analytic Workspace in the same region. So suppose you have Log Analytic Workspace 1, and here you have one Sentinel. So with your Sentinel, Log Analytic Workspace is connected. So the same Log Analytic Workspace cannot be connected with Sentinel 2 or some other Sentinel instance. But a single Sentinel uh, can have the multiple Log Analytic Workspace: LAW1, LAW2, LAW3. And data retention is configured at the workspace level, so which is default 90 days free. With Sentinel and archival is up to 7 years. So everything, the retention period and all, can be set here in Log Analytic Workspace. So the pro tip: know that you can cross query multiple workspace using this query and the table, and you can write the syntax in KQL. So this is for this is crucial for the MSSP provider. So using Lighthouse, they access the multiple workspace and it is easier to query the data from one workspace. So you don't query Sentinel directly, you query the workspace using KQL. So you can mention that data retention is configured at workspace label, interviewer like this detail. All right, question number 3. What are the 4 main pillars of Microsoft Sentinel? So Sentinel works in 4 main stages. So this is Sentinel, and Sentinel have collect. So Sentinel collect the data, and then Sentinel detect threat, and then we can investigate and hunt here, and then number 4, we can respond on the security incidents. So these are the 4 main pillar. So the 4 core capability pillars of Microsoft Sentinel are collect. So you are going to ingest security data at the cloud scale from Microsoft, third party data and custom connectors or sources via data connectors, and then detect. So you can detect built-in custom analytic rule, Microsoft machine learning modules and fusion alerts to surface the threat, and then investigation. So you can use the investigation graph, UEBA, and incident timeline to understand scope, then respond. So automated response with logic app based on playbook, automation rules, and SOAR workflow. So in the collection part, you bring your own data like AD data or firewall data or endpoint data. You can collect data here, and then you can create rules here and built-in rules to detect the threat. For example, multiple failed login, and then you can investigate. So you can analyze the alert using graph, timeline, entities, and then you can take actions using SOAR playbook. So there is also hunting part. So like proactive searching for the threat. So hunting means search threat proactively. So interviewer want to see if you understand the full life cycle of SOC operation. So this is the 4 main pillar and the SOC operation life cycle. All right, question number 4. Explain the difference between analytic log tier, basic log tier, and auxiliary log tier in Sentinel. So Microsoft introduces tiered log storage to optimize cost versus query capability. So this question is about cost optimization, and it is very important in real jobs. So there are 3 type of log. Number 1, analytic log. So these are full featured log where you can index all the data, query via KQL, and create alert dashboard. And this is a default tier, and the pricing is around $2.30 per GB ingestion. While the basic tier, so these are very cheaper but limited, and the cost you can see around 0.50 GB per day per GB, and limited retention. So this has very limited retention, only 8 days interactive log you can get, and there is no alert capability. And also this is simplified query capabilities. So this is good for the verbose noisy log like firewall flow, proxy log, etc., but not for your important log like security data or EDR data. Then we have auxiliary log. So these are for long term storage. So this is mainly for compliance. This is very cheapest tier and long term retention supported like up to 7 year. And here you can do the KQL query uh, for compliance archival. So the key insights are like smart engineers balance cost versus detection capabilities. So a modern Sentinel architect route, high fidelity security event to analytic, and noisy telemetry to basics, and compliance data to auxiliary. So this optimize both cost and detection coverage. So I would, you can say I would store high value security log in analytic and noisy logs in basic. So the point you can mention here, security events can be stored in analytics log. So this is your live logs, and then noisy logs like snmp trap you can save in basics, and some other log for compliance like app data you can save in auxiliary for 5 year or 7 year retention. All right, what is Microsoft Sentinel Content Hub and how does it accelerate deployment? So a content hub is like an app store inside the Sentinel. So you can get all the applications, connectors, uh, solutions, everything from content hub. So it's a centralized marketplace within Microsoft Sentinel, and that provide packaged out of box security content like solutions. So it bundles data connector, analytic rule, workspace, workbook, playbook, hunting query, dashboard, and watch list for specific products. So suppose you have Microsoft Defender for endpoint, AWS, and Palo Alto network. So Microsoft have a package for it. So there will be a package like AWS, which includes all the rule, all the dashboard, connectors. So you need to go in the content hub and just download it from here, and some standalone items like individual rule, workflow, and playbook also available. So content hub replace the old GitHub based deployment model and integrate with Azure DevOps CI/CD pipeline for GitHub operation based on content management. So this is basically for the content management. And the deployment tips, so in enterprise deployment you can use the Sentinel as code using the GitHub repository and Azure Bicep ARM based templates to deploy content hub solution to scale across multiple workspace. So this saves time and standardized deployment, and content hub apps accelerate deployment and ensure best practice configurations. All right, explain Microsoft Sentinel Fusion detection and how it reduce alert fatigue. So Fusion is one of the most powerful feature in Microsoft Sentinel, and this uses the machine learning capabilities to combine multiple low-level alert into one high confidence alert. So this also correlate the low fidelity signals across multiple data sources to detect the sophisticated multi-step attack with high fidelity. So Fusion ingest signal from 30 plus Microsoft and partner products like Defender Family, Intra ID, Azure Active Directory, or Azure Activity, and this applies skill chain reasoning. So this is going to correlate an anomalous login in the stage 1 with a suspicious Azure resource creation in stage 2 to reduce the high fidelity fusion incidents. So stage 1 it is going to detect the anomalous login, and in stage 2 it is going to detect the Azure resource creation. This is basically provide a correlated events. So the problem is in your SOC you get 100 of alert, right? So this is called the alert fatigue, and the solution, so the solution is Fusion correlates alert. So Fusion alerts can save your noisy SOC activities. For example, like suspicious login, then privilege escalation, then unusual VM activity. So instead of 3 alert, Fusion create only 1 alert or 1 incident. So this reduce the alert fatigue by replacing 10s of individual alert with one correlation events. And Fusion alert map directly to MITRE attack tactic and include evidence from all contributing signals. So Fusion cannot be disabled selectively for a specific scenario because it is inbuilt Microsoft machine learning capability, and it is always on machine learning service. So you can review it detections but not tune individual rule within it. So Fusion is automatic, you cannot modify it. Then we have what is UEBA in Microsoft Sentinel and what table does it populate. So a UEBA stands for user and entity behavior analytics, and it uses machine learning to understand normal behavior and detect anomalies. So this build baseline behavior profile for user, device, application, and IP address using machine learning, then surface anomalies as risk score. So UEBA is an engine which going to create the baseline for entities like user, devices, your apps, IP addresses, etc. So the key table populated like behavior analytics. You can search with behavior analytics, identity info for identity related events, identity directory events, then behavior analytics, which contain the activity insights. So this was action layer for the user, and then investigate priority scores and the user peer group insights. So UEBA require enabling in setting uh, entity behavior and mapping data sources. So at least one Entra ID connector should be enabled. So UEBA is not enabled by default. You need to go in the setting, and then you need to uh, check mark the button for UEBA. And the hunting tips, you can use the tables like behavior analytics, where investigation priority is greater than 5 is a great baseline hunting query to surface the high risky user activity. So this help detecting insider threat or compromised account. So in interview you can say UEBA help prioritize high risk user using behavior based scoring. All right, next question we have: what are watch lists in Microsoft Sentinel, and provide a practical use case. So watch lists are basically reference data. So watch list equal to reference data. So think of them as custom list you upload in Microsoft Sentinel in CSV format, and watch list are reference data tables uploaded at CSV format, and we can join them with KQL queries, and we can use it in analytic rule logic. So they act as lookup tables. So basically they are the lookup table. So if you have used Splunk, you know the lookup table, right? So these are the lookup tables. So they are stored in get watch list and then watch list alias in KQL, and you can utilize them by calling this alias and this operator. And this also supports large list up to 10 million rows with a large watch list features. And what are some practical use case? So think of them as custom list you upload in Microsoft Sentinel. For example, uh, list of BIP users, and list of list of malicious IP, and list of the trusted systems. Then you can use them in KQL queries. So allow list of known good IP ranges. So you can create allow list for your VPN, CDN ingress IPs, and then you can suppress those IPs from alerts, and you can save the false positive triggering. Then high value asset list. So suppose you have multiple servers which are crown jewel servers. So you can generate high priority incident when these systems are accessed. So suppose your database, your financial systems or servers, you can upload as watch list. And if any suspicious activity happens like anomalous login or unauthorized access, you can generate an alert. Then user HR termination feed. So you can send a feed into Microsoft Sentinel by uploading the CSV format and trigger automated offboarding workflows. And also you can manage the threat intel piece, the IOC feed using CSV data. So you can upload the IP ranges, IP address, hash, domain for your custom TI matching. So instead of hard coding values in queries, you maintain them separately using watchlist, and watchlist improve flexibility and maintainability of detection logic. All right, question number 9. How does Microsoft Sentinel handle multi-workspace and multi-tenant architecture? So this comes in enterprise environment. So suppose you have enterprise environment and you have a company here which have multiple departments. So suppose your company name is XYZ, having multiple department, IT, network, security, or there is a MSSP like PWC or something. They have multiple clients, right? So client 1, client 2, and client N. So they use the multi workspace environment. So they have workspace 1, workspace 2, workspace 3, and then they can use Azure Lighthouse. So Azure Lighthouse is a solution that can help in managing multiple customer Sentinel workspace from single pane. So PWC or any MSSP can have a single pane, and from there they can manage the multiple clients workspace. So this is where the Azure Lighthouse help. And so for enterprise MSSP deployment, Sentinel support cross workspace querying and multi-tenant management. So we discussed about the Lighthouse. Lighthouse enable the MSSP provider to manage multiple customer Sentinel workspace from single pane of glass with the delegated RBAC and full API access. And then cross workspace queries, so they can write the cross workspace query from here, the KQL query, by adding the workspace ID here, and then they can query cross workspace. Centralized versus distributed. So central workspace ingest all data like simple potential data issues and all, but the distributed keep data local with cross workspace queries for global view. So suppose there is a company in USA but their office is in India, Japan, Germany. So they can create the multiple workspace and then manage it from USA. And the Sentinel Workspace Manager. So this pull the Log Analytic Workspace, Workbook, Automation rule to multiple workspace centrally. So the design decision. So you can like data laws like GDPR, data residency requirement, often force distributed architecture, even when the centralized would be technically simpler. Like here, there is a single SOC which is monitoring 10 companies and centralized versus distributed architecture we can see here. And in an interview you can mention data residency and compliance is very important for this architecture, so that will add some value in your interview. All right, so what are the key RBAC role in Microsoft Sentinel? So this is about the access control we are talking about. So the main roles in Microsoft Sentinel are Microsoft Sentinel Reader, Microsoft Sentinel Responder, Microsoft Sentinel Contributor, Playbook Operator, Sentinel Automation Contributor. So Microsoft Sentinel uses Azure RBAC. RBAC means role based access control. So suppose you are a SOC analyst, so you don't need to contribute in Microsoft Sentinel. You need to respond on the incident and you need to read the data, right? So that's why this RBAC access is very important. So reader can only view, they can view the incident, dashboards, queries, but they cannot edit. So this is very important part. And Microsoft Sentinel Responder can read and also assign and update the incident and run the playbook. So this is very ideal for SOC analyst. And then Microsoft Sentinel Contributor. so they can respond on the attack or alerts. They can create or edit existing rule or create new rule, and also dashboards. They can create playbooks. They can enable the data connectors. So this is more admin kind of role. And then Sentinel playbook operator, so they can trigger playbook only, no other access. So if you have a automation team or a separate engineer for uh, SOAR, so this role is helpful in this case. Then Microsoft Sentinel automation contributor, so this require for Sentinel to call logic app in automated automation rule. So this is a kind of service principle. So least privilege, we need to follow the zero trust model here. So SOC tier 1 analyst should have the responder role, and content engineer get the contributor role. So never assign honor at workspace label to Microsoft Sentinel operators, right? So always follow the least privilege principle while assigning the role. Never give full admin access unnecessarily. What is KQL and what are the most commonly used operator in Microsoft Sentinel queries, the KQL queries? All right, now we move into KQL. So this is one of the most important part in Microsoft Sentinel. So KQL stands for Custo Query Language. And instead of just saying that, explain it like this. So KQL is a language we use for query and inside the Log Analytic Workspace. So KQL, this is your Log Analytic Workspace, and we can write the KQL queries to query data and get the result directly from Log Analytic Workspace. So if you know KQL, you can relate it, but KQL is optimized for log analysis and time-based data. So KQL is a language we use to query log inside your Log Analytic Workspace, and here are some common operators. So this also used in Azure Monitor, Log Analytic, Microsoft Sentinel, and Microsoft Defender XDR. And the most commonly used operator in Microsoft Sentinel are where. So this filter the rows, and this is for filtering. So like here you can see one example where event ID equal to 4624. Then we have project. So project is for selecting the specific column. So this is going to select the specific column in the results. And then summarize. So this aggregate data like summarize count by account name, and then extend. So this add some computed columns, and then join. So if you want to join two tables, suppose you want to join security incidents with your identity table, so you can join using common field. And then union, so union combine the rows from multiple tables. Then mb expand, so mb expand is a dynamic array to rows, and then parse and extract. So this help in parsing the raw data. Then render, so render help in visualize results in time chart, bar, pie, etc. So in real SOC work, we don't just read log, we query pattern, and KQL help us turn raw log into meaningful detection. So you can say KQL is optimized for high speed querying on large scale telemetry data. All right, so write a KQL query to detect multiple failed login followed by a successful login. So this is brute force success within 1 hour. So this is how you can start, and this is a classic real world detection. So suppose there is a scenario, an attacker try to multiple password and then finally log in successfully. So they try multiple password, fail, and then one got success. So what we can find, so we can start with the threshold. So we given the threshold 5. So let threshold equal to 5, then time window is 1 hour. And also there are some filters. So let failed login equal to security event. So this is the data table where it is going to check, and then event ID. This is very important, 4625. So this is going to find the failed login 4625. Every failed login is going to record here. and then summarize failed count equal to count, then last failed is maximum time generated by target account IP address, then it is going to create a bin time generated and time window, and then the first step is complete. First step. Now we can find the successful login. So let successful login equal to security event, and then 4624, which is for login success, and then project success time equal to time generated target account IP address, and then we are going to find the failed login again. So failed logins where failed count is equal to and uh, like greater than or equal to threshold, and then join kind inner equal to successful login on target account IP address where success time between last failed plus time window, and then project target account IP address failed account last failed success time. So the key pattern we can use here: bin for time bucketing and let for reusable subqueries, and the join kind equal to inner for the both conditions. So we are correlating two events here: multiple failure followed by success within a time window. So this is a real world explanation, and this indicates the credential stuffing or brute force attack. So you can use this line in the interview: this is an example of multi-event correlation detection. So that one sentence make you sound experienced. So this is multi-event correlation detection. Multi-event correlation detection. All right. What is the difference between join kinds in KQL and inner, left outer, full outer, left anti, etc.? So this is very important concept, especially for detection logic, and there are multiple types we are going to discuss here. So KQL join kinds control how rows are matched between the left and right tables, and the first one is inner, uh, the inner join. So this returns rows that matches in both table like intersections. So this is default for security correlation. So we can say this is the inner join. Inner, this is the inner join. And then the next one we have left outer. So all rows from left table with matching right rows if available, so none for the non matches. So this is the left outer, this is your left, and this is your outer. This is left outer. And then we have full outer. So this is going to join all rows from both table and nulls where no matches. So this is uh, your full outer. Full outer. Full outer. Okay. And then we have left empty. So this returns rows from left table that have no match in the right. So this is critical for detection like show me events not in my allow list. So this is left empty. This is left empty. Left empty. All right, then we have right semi. So this returns rows from right table that matches left. This is useful for which IOCs from my watch list were seen. So this is right semi. Right semi. There are some more available like right outer. So this is right outer. Right outer, and then right semi, and then uh, right NT, etc. So the common pattern is like left NT with a watch list is how you detect traffic to known bad IPs while excluding the allow list conditions. So there is a real world example. So suppose I have a watch list of allowed IP. Now I want to detect suspicious IPs. So we can use the left NT to find the IPs not in the allow list. So you can say in the interview, left NT is commonly used for detection anomalies against baseline of the allow list. All right, next we have how do you use dynamic column and MB expand in KQL? Give a security example. So MB expand the arrays or property bags for the dynamic columns into separate rows, and this is essential for JSON heavy data like Azure Activity Log or Defender XDR events. So here we have an example, detecting users with multiple admin role assigned simultaneously. So one log entry which contains the multiple value called array. So here you can see the query. So we have an audit log where the operation name equal to add member to the role, then expand target user to a string target resource user principal name. Then we are going to extend it the role name. So this is going to provide the target resource, then modified properties dot new value, then MB expand the role assignment. So this is going to parse the JSON file and provide the target resource. Then we can summarize the role and make a set of the all roles, and then role count like d count role name by target user where role count is greater than 3. So MB expand convert one complex record into multiple simple records. So this is very critical for parsing nested security logs. So parse JSON before MB expand when the column is stored as a string rather than native dynamic type. The next question we have, what are KQL stored function and how do you improve detection engineering? So this is about writing smarter and reusable code. So sorted functions, also called workspace functions, are reusable KQL query logic saved in the uh, logic in the Log Analytic Workspace that can be referenced by name in the query and analytic rule. So this is created via let function name equal to parameter type, then your query, then function name arrays as workspace functions saved as a function pane. So this is a function actually. So this enable the DRY, the don't repeat yourself detection engineering, and this also update the function once all rule consume it and update automatically. And this is commonly used in like normalizing parsing functions like parse, DNS log, entity extraction helper, common allow list logic, and there is a ASIM, the Microsoft Advanced Security Information Model ASIM parsers are incompleted uh, parsers are implemented as workspace functions like IAM DNS, IAM network sessions. So this provide the schema normalized data across all DNS network and sources. So if something change, you update once, not 10 rule. So this is the actual value of the functions. So stored functions help maintain consistency and reduce duplications. All right, next question we have, explain the ASIM Advanced Security Information Model and why it is matter for detection rules. So this is where many candidate fail, but if you explain this well, you stand out. So ASIM in Microsoft Sentinel normalized framework that provide a unified schema across heterogeneous data sources. So the problem is, so like different tools have different log formats. For example, there is a firewall A versus firewall B. So they have different field. They have different field log tables, right? And the solution. So the solution is ASIM. Solution is ASIM. So this normalize the data into standard format, and ASIM create a common schema across different data sources. So this solved the problem of writing the same detection logic multiple times for different data sources. So ASIM parsers are KQL functions and map vendor specific schemas to standard ASIM schemas like network sessions, DNS, authentication, process, file event, etc. So in DNS queries, DNS data across all configured DNS connectors like Windows DNS, Infoblox, Cisco Umbrella with a single query, and analytic rule written against ASIM parsers automatically, and they work with any feature data sources that has a ASIM parser. So this zero rule updated needed. That mean ASIM create a common schema across different data sources. So instead of writing uh, one rule for Palo Alto and one rule for Cisco, you can write one rule using ASIM. So ASIM enable vendor agnostic detection engineering, and that sounds very strong. So the best practice is write all new detection rule against ASIM parsers rather than native tables. So this is Microsoft official guidance for production SOC deployment. Next question we have, how do you query a watch list in KQL? So this is very simple but important. So watch lists are accessed using get watch list functions and then the alias. So how it works? So you use get watch list and then your alias like name or something. Uh, so like you have malicious IP list, now match log against it. So here is one example, detect connections to known bad IP from a watch list. So this is your uh, like let bad IP equal to get watch list malicious IP. So this is your watch list calling, and then project search key, and then you are going to uh, call the common security log where the device action is not in deny or drop, where the destination IP in bad IP, and then summarize count by source IP, destination IP, and device name. So this is going to provide you the result of the malicious and bad IPs. And the performance tips, materialize large watch list like let WL materialize get watch list and name to avoid re-evaluation of each lookup join. So watch lists are very helpful for IOC based detection and the dynamic detection. You can upload list without changing your query. All right, next question we have, write a KQL query to detect DNS beaconing, the periodic outbound DNS request to the same domain. So you can start with the DNS beaconing in C2 indicator, the command and control indicator, where malware call home at regular intervals. So this is a real attacker behavior. And what is beaconing? So malware calling its command server at regular intervals. And the detection logic, you can check the DNS events where the time generated in 24 hour, and the subtype is lookup query. So this is DNS lookup query subtable, and then summarize request count, and then make a list of the generated, and then 1000 by client IP and name, and then request count is greater than 50, then call it in result, and then extend the time difference, time series difference, etc. And then regularity, you can create a series state dynamic here, and then project client name, request count, std deo, etc. So you can check the same domain repeated queries and the consistent timing. So this is a like simple query, so you need to check the same domain and then repeated queries and then consistent timing. So this will help you to identify the beacon. So the real world impact here is the C2 detection. By writing this query, you can detect the C2 and then malware communicating. So malware communication tracking. So low variance in time intervals indicate the automated weakening, and low standard deviation of inner request intervals is the key beaconing indicator here. So combined with the DGA storing like string size analysis for higher fidelity. Next question we have, what is the difference between search, find and union in KQL for a cross table investigation? So this is about performance and efficiency. So the search equal to search everything, search everything. So you can start like this, you can type the search and then 8.8.8.8. So this is going to check everything and this is super slow. So the full text search across all table or specific table, this is very slow. Use only for ad hoc investigations like search 192.168.1.100, and then we have find. So find give you the search multiple table with conditions. So this is better. So this is structured search across multiple table with KQL predictions. So you can type like this, find where IP address equal to 192.168.1.100, and this is very fast. Then search, and this returns table of origins. Then we have the union. So union combine known tables, and this is very fast. So this combine row from xpx this combine row from explicitly named table, and this is fastest for known tables like union security event sign in log, then where the account equal to Bob. So if you know where data is, you can use union, otherwise you can go for search or find. And the performance hierarchy, so you can start with the union, find, search for speed, and you can use search only when you genuinely don't know which table contains your data. So if you're blind with the data, you can start with search, and union is preferred in production queries due to performance. Then we have explained time series analysis in KQL and how it is used for anomaly detection in Sentinel. So this is more advanced but very powerful. So instead of looking a single event, we analyze pattern over time. So KQL include native time series function that power machine learning based anomaly detection. So we can make series. This creates time series array from aggregated data over regular bins, and then series decompose anomalies. So this detect anomalous spike dips using seasoned decomposition, and then series outliners. So this talk about the outline detection for simpler anomaly identification. For example, detect anomalous authentication volume using this query. So this is basically used in detecting a spike, unusual behavior, and then trending deviations. So in interview, you can say time series analysis enable behavioral anomaly detection beyond static rule.